A 30-year-old HVAC technician in Northern Virginia just signed a contract that will pay him more this year than the software engineers whose data centers he's cooling. While the rest of the world is terrified of AI replacing their jobs, a small group of tradesmen have realized that Silicon Valley is actually making them rich. Today, I'm going to show you the $60 billion gold rush that nobody, chavvy in the tech world, wants you to see. I spent 30 years building technology systems. I know exactly how they work. Not just the code, but the physical infrastructure underneath. Every server needs power. Every processor generates heat. Every cable needs conduit. Every building needs plumbing, fire suppression, climate control, and a structural foundation rated for loads that would collapse a standard commercial building. The entire artificial intelligence revolution, every chatbot, every image generator, every large language model, every autonomous system runs on physical infrastructure that human beings have to build with their hands. And right now, there aren't enough of those human beings to meet the demand. That's the irony nobody's talking about. The technology that's eliminating white-collar jobs is simultaneously creating a gold rush for blue-collar workers. The same companies that are replacing marketing departments with AI tools are spending $60 billion in 2026 alone on data center construction. Microsoft, Google, Meta, Amazon, they're in a building war. And every one of those buildings needs electricians, plumbers, HVAC technicians, welders, heavy equipment operators, and concrete specialists. Forbes ran a piece in February 2026 with the headline, "The real talent war isn't in Silicon Valley, it's on the job site." And they're right. The bottleneck on the AI revolution isn't compute power. It isn't model architecture. It isn't training data. It's the fact that these companies cannot find enough skilled tradesmen to build the physical plants that their technology requires to function. Let me explain why this matters structurally, because it's not just a temporary hiring spike. This is an architectural shift in where value flows in the economy. And I want to walk you through the specific systems inside these facilities so you understand the scale of what we're talking about. A data center is not an office building. It's one of the most complex physical systems on the planet. The electrical demands alone are staggering. A single hyperscale data center consumes between 50 and 200 megawatts of power. To put that in perspective, that's enough electricity to power 40 to 160,000 homes. The electrical infrastructure required to deliver that power, the substations, the transformers, the distribution panels, the backup generators, the uninterruptible power supply systems, the automatic transfer switches, the bus ducts, the cable trays running miles of copper and fiber, requires hundreds of licensed electricians working for 12 to 18 months. And that's just one facility. Microsoft announced plans for over 100 new data centers in 2026. Google is building at a similar pace. Meta is expanding its infrastructure across 3 continents. Each one of these facilities is a multi-year construction project employing hundreds of tradesmen at wages that are climbing every quarter because the labor supply can't keep up with the demand. And I need you to understand what redundancy means in this context, because it's a multiplier that most people outside of infrastructure never think about. A data center cannot go down, not for a minute, not for a second. The financial consequences of downtime for a hyperscale operator are measured in millions of dollars per hour. So every critical system has a backup, and the backup has a backup. The industry calls this 2N or 2N plus 1 redundancy, meaning every component is fully duplicated with an additional spare. The primary power feed has an independent secondary feed from a different substation on a different grid path. The backup generators, and we're talking about rows of diesel generators the size of shipping containers, have their own fuel supply, their own control systems, their own cooling, their own exhaust systems, and their own fire suppression. The uninterruptible power supply systems have battery banks that could fill a gymnasium. Every layer of redundancy is another layer of installation, another layer of wiring, another layer of conduit, another layer of testing and commissioning. When you hear one data center, think 3 data centers stacked on top of each other in terms of the actual electrical work required. That's why the demand for electricians in this sector is so extreme. It's not 1-to-1 with square footage, it's 3-to-1 minimum. And every single connection has to be right. There's no close enough when you're wiring a facility that can't tolerate a flicker. The cooling systems are equally complex, and this is where the industry is undergoing a shift that's creating an entirely new category of high-value tradesmen. Traditionally, data centers used raised floor air cooling, push cold air under the floor, let it rise through the server racks, capture the hot air at the ceiling, cool it, recirculate. That worked when server density was moderate. It doesn't work anymore. The processors running AI workloads, the GPUs, the tensor processing units, the custom silicon chips that companies like Google and Amazon are designing specifically for AI, generate thermal loads that air cooling simply cannot handle efficiently. We're talking about individual chips pulling 400, 500, 600 watts, racks that draw 40, 50, 80 kilowatts. You cannot move enough air through a rack to cool that. The physics don't work. So the industry is moving to liquid cooling, and this transition is the single biggest opportunity for tradesmen in the data center space right now. Direct-to-chip liquid cooling, where coolant flows through cold plates mounted directly on the processors. Rear door heat exchangers that capture heat at the back of the rack with liquid-cooled coils. Full immersion cooling where entire servers are submerged in tanks of non-conductive dielectric fluid. This is precision plumbing and precision HVAC at a level that simply didn't exist 5 years ago. The technicians who can install and maintain these systems are in a class by themselves. There aren't training programs for this yet at most community colleges. The curriculum hasn't caught up. The knowledge is being built on the job, on active construction sites, by the guys who are figuring it out in real time. And those guys are writing their own ticket because nobody else knows how to do what they do. A hyperscale data center can produce thermal loads equivalent to a small industrial furnace running 24 hours a day, 365 days a year. The cooling infrastructure required to manage that, the chillers, the cooling towers, the liquid cooling distribution manifolds, the precision air handlers, the water treatment systems that prevent corrosion and biological growth in the closed loops, the leak detection systems that monitor every joint and fitting, is some of the most sophisticated climate control engineering in the world. An HVAC tech working on data center projects in Northern Virginia, Dallas, or Phoenix is billing at rates that would make a mid-career software developer uncomfortable. I've talked to contractors in this space who can't fill positions at $120,000 a year because the demand outstrips the available workforce by that much. Then there's the plumbing. You don't think about plumbing when you think about AI, but every data center has extensive water systems for cooling, for fire suppression, for humidity control. The newer liquid-cooled facilities use water-cooled server racks that require precision plumbing at a level of complexity most residential plumbers never encounter. We're talking about closed-loop systems with precise flow rates measured in gallons per minute per rack, temperature monitoring at every junction, filtration systems that remove particulates down to the micron level, chemical treatment systems that maintain exact water chemistry to prevent scale buildup and corrosion. A single fitting that leaks in a room full of servers can cause hundreds of thousands of dollars in damage in minutes. The plumbers working on these systems aren't unclogging drains. They're installing cooling infrastructure that costs millions of dollars per installation, and they're getting paid accordingly. This is what I describe in my book, Iron Logic, as structural stability. The principle that real wealth isn't income. Real wealth is resilience, the ability to withstand disruption. The tradesman working on AI data centers has the ultimate form of structural stability because his skills are in demand precisely because of the disruption that's destroying other careers. The more AI advances, the more physical infrastructure it requires. The more infrastructure it requires, the more tradesmen it needs. His income doesn't compete with AI. His income is funded by AI. That's not a fragile position. That's an anti-fragile one. Every advancement in the technology that's threatening white-collar employment is simultaneously increasing demand for his labor. He doesn't need to fear the disruption. He's building the foundation it stands on. Now let me run the asymmetric risk math from my book, Rig the Game, because I want you to see why this positioning is so strategically powerful compared to what most people are doing right now. Right now, millions of white-collar workers are scrambling to learn AI tools. They're taking courses on prompt engineering. They're getting certifications in AI-assisted marketing, AI-powered project management, AI-enhanced data analytics. They're retraining themselves to work alongside the technology that's replacing their colleagues. And here's the problem with that bet. The tools change fast. The prompt engineering techniques that work in 2026 may be obsolete by 2028. The AI marketing platform you spent 6 months mastering may not exist next year. The certification you just paid $2,000 for may be irrelevant by the time you hang it on the wall. You're investing your time and money in learning to operate a specific version of a technology that's iterating faster than any human can keep pace with. The downside is uncapped. You can retrain continuously and still fall behind because the target is moving faster than you can run. Every 6 months, there's a new model, a new interface, a new paradigm that makes the last one look primitive, and the certification you just earned is already stale. Compare that to the tradesman's bet. He's betting on the physical infrastructure that AI requires to exist. That infrastructure doesn't iterate every 6 months. A data center built in 2026 will be standing for 20 to 30 years. It will need maintenance, upgrades, and expansion for its entire operational life. The electrical systems will need certified electricians to service them, not once, but continuously, because load demands increase as computing power scales. The cooling systems will need licensed HVAC techs, even more so as facilities transition from air cooling to liquid cooling, which requires retrofitting. The plumbing will need qualified specialists. The building doesn't care whether the AI running inside it is GPT or Claude or Gemini or something that hasn't been invented yet. The building needs power, cooling, and water regardless. The tradesman's skills are anchored to physical reality, not to a software version number. His downside is capped. The worst case is that data center construction slows and he goes back to commercial or residential work, which is also in high demand because of the same nationwide workforce shortage. His upside is essentially unlimited as AI scales, because more AI means more data centers, means more demand for his labor. And here's the part nobody talks about. Construction is only the first revenue stream. Once the building is operational, it needs ongoing maintenance. A data center maintenance contract is a recurring revenue stream that can last decades. The electricians, the HVAC techs, the plumbers who built the facility are the first call when something needs servicing because they know the systems. That's not a one-time job. That's an annuity. That's asymmetric risk. Low cost of entry. Most apprenticeship programs pay you while you learn, so there's no student debt. Capped downside. Your skills work across multiple sectors, even if data center construction slows. Rising upside tied to the single biggest technological expansion of the century. If you designed the perfect strategic position for a young man entering the workforce right now, this is what it would look like. Let me tell you about a contractor I know in the Dallas-Fort Worth area. He started as an apprentice electrician at 19. No college, no debt. Spent 4 years learning industrial electrical on commercial projects, hospitals, manufacturing plants, distribution centers. When the first wave of data center construction hit Texas around 2022, he was 27 with a journeyman's license and solid commercial experience. He got hired onto a data center project and realized within 3 months that the demand was unlike anything he'd seen. The general contractors were offering overtime at double rate and still couldn't fill shifts. Guys were driving in from Oklahoma, from Louisiana, from Arkansas, because the work was that plentiful and the money was that good. He worked that project for 18 months, saved aggressively, lived like he was still an apprentice, even though he was making more than he ever had. At 29, he started his own electrical subcontracting firm with a crew of 4 guys he'd worked alongside on site. By 31, his firm had 12 licensed electricians and 3 active data center contracts. His gross revenue last year was over $2 million. He's 32 years old, no degree, no student loans. And the pipeline of work in front of him stretches to 2030 because the construction schedule for data centers in Texas alone is booked out for years. That's not a fairy tale. That's the math working exactly as the asymmetric risk framework predicts. He positioned himself at the intersection of critical demand and constrained supply, and the economics did the rest. Now let me get specific about the pathway, because I'm not interested in giving you analysis without a protocol. If you're watching this and you want to position yourself for this boom, here are the 4 steps. Step 1, pick your trade based on data center demand, not on what's traditionally popular. The highest demand specialties in data center construction right now are electrical, specifically high voltage and industrial electrical, followed by HVAC with a focus on precision cooling and liquid cooling systems, followed by plumbing with an emphasis on closed loop and process piping systems. Welding is also in critical demand, particularly for structural steel and pipe welding on cooling infrastructure. These aren't the only trades that benefit, but they're the ones closest to the money. If you don't know which to choose, go electrical. It has the broadest application across the most systems in the facility and the highest consistent demand. Step 2, enter an apprenticeship or training program that specifically serves the commercial and industrial sector, not residential. I cannot stress this enough. The skills overlap, but the pay scale, the project complexity, and the career trajectory are completely different. A residential electrician and an industrial electrician both hold licenses. The industrial electrician working data center projects makes 50 to 80% more. When you're choosing your training path, ask one question. Does this program place apprentices on commercial or industrial job sites? If the answer is residential only, keep looking. Look at the IBEW, the International Brotherhood of Electrical Workers, and their apprenticeship programs, particularly the ones affiliated with large-scale commercial contractors. Look at programs through organizations like NECA, the National Electrical Contractors Association. Target your training toward the higher value application from the start. Step 3, get in the geographic pipeline. Data center construction is concentrated in specific regions. Northern Virginia leads the country by a wide margin and has for over a decade, followed by Dallas-Fort Worth, Phoenix, Columbus, and increasingly the Southeast. Atlanta, Nashville, Charlotte, as companies diversify their infrastructure locations to reduce geographic risk. If you're willing to relocate or travel for work, you position yourself in the highest demand markets where the wage premium is strongest. A lot of these projects offer per diem and travel stipends on top of base pay, sometimes $30 to $50 a day in additional compensation, plus housing allowances, because they can't source enough local labor. A young man willing to go where the work is has an immediate and compounding advantage over one who won't leave his hometown. The money follows the willingness to move. Step 4, build toward ownership. This is the end game, and it's where the real wealth lives. The goal isn't to work on data center projects for 30 years as an employee. It's to build enough expertise, enough reputation, enough relationships with general contractors and project managers, and enough capital to start your own specialized contracting firm. A contractor who can field a crew of licensed electricians or HVAC techs for data center projects is in a position of extraordinary leverage. The clients, Microsoft, Google, Meta, their general contractors like Holder, DPR, Fortis, have billions of dollars in construction budgets and not enough qualified subcontractors to execute the work. The pricing power sits with the contractor who can deliver skilled labor reliably and on schedule. If you build that operation over 5 to 7 years, you're not just earning a wage. You're capturing a percentage of the $60 billion infrastructure build out. And then you're capturing recurring revenue from maintenance contracts on the facilities you built. That's the sovereign position. That's structural stability that doesn't depend on any single employer, any single project, or any single technology platform. This is what sovereignty looks like in practice. A sovereign man doesn't panic when he sees headlines about AI replacing jobs. He doesn't doom scroll through articles about which careers are going extinct. He reads the structural data underneath the headline. He identifies where the disruption creates demand instead of destroying it, and he positions himself there, not with a degree in artificial intelligence, but with a set of physical skills that artificial intelligence literally cannot function without. The AI revolution needs somebody to build it. The servers need power. The processors need cooling. The buildings need plumbing. The redundancy systems need wiring. The liquid cooling loops need fitting. The backup generators need commissioning. And the men who can deliver those things are going to be paid like the critical infrastructure they are, because that's exactly what they are. Critical infrastructure, not in the metaphorical sense, in the literal structural, the lights don't stay on without them sense. Every AI data center needs a plumber. And right now, that plumber is out earning the engineers who designed the system running inside. If you like this content, please like and subscribe. It keeps the motor running. And if you'd like to learn more, check out my books on Amazon or click the links below.